module, first we will study about the alkanes. Then we will study general introduction, preparation, physical properties, chemical properties, and uses of methane.
Use of gobar gas plants in rural India is increasing day by day. Do you know what is the main constituent of gobar gas produced by them? It is methane, a hydrocarbon. Can you tell what are hydrocarbons? Here is a hint for you. The term is self-explanatory. Hydrocarbons are the compounds containing only hydrogen and carbon atoms. The number of hydrocarbons is too large. So for better understanding, they are classified into three major groups, namely alkanes, alkenes, and alkynes. In alkanes, at least one carbon-carbon single bond is present. Alkenes have at least one carbon-carbon double bond, while in alkynes, at least one carbon-carbon triple bond is present. Let us know more about alkanes. Alkanes are the saturated hydrocarbons and are commonly known as paraffins. This word is made up of two words, param, meaning little, and affins, meaning affinity. They are less reactive as compared to alkenes and alkynes. What is the general formula of alkanes? The general formula of alkanes is CnH 2n plus 2. What does this mean? If we substitute n is equal to 1 in this expression and solve, the hydrocarbon thus formed is CH4 and it is called methane. And if we substitute n is equal to 2 in the above expression and solve, the hydrocarbon thus formed is C2H6 and it is called ethane. Moving on, we will learn how to write the IUPAC names of alkanes. The names of alkanes end with suffix -ane. The first part, that is prefix of the name, indicates the number of carbon atoms present in the chain. Here you can see meth is used for representing one carbon atom chain, eth for representing two carbon atoms chain, and prop for representing three carbon atoms chain. Similarly, bute is used for representing four carbon atoms chain. Pent is used to representing 5 carbon atoms chain, and hex is used for representing a chain comprising of 6 carbon atoms. Here structures of some alkanes like methane, ethane, and propane with their formula are shown. Now we will learn about homologous series of alkanes. General formula of alkanes is CnH 2n plus 2, where n denotes the number of carbon atoms. Here you can see the first 8 members of the homologous series of alkanes. If you look carefully, you will notice that there is a difference of CH2 group between successive members. Moving on, we will now study about the isomerism in alkanes. If both the hydrocarbons have the same number of carbon and hydrogen atoms, then why are they given different names? It is because the compounds having the same molecular formula but different structures have different properties and are called isomers. Here you can see all the possible isomers of pentane, namely pentane, 2-methylbutane, and 2,2-dimethylpropane. This table shows you the number of possible isomers of the first 7 alkanes. Now it's time to have a learning check. The formula that represents an alkane is, and your options are C5H10, C6H14, C5H8, and C4H7. The correct answer is option B, C6H14. The general formula for alkanes is CnH 2n plus 2. For n equals to 6, the formula obtained will be C6H14. Thus it is an alkane. Going forward, we will now study about the sources of alkanes. The major sources of alkanes are natural gas and petroleum. Natural gas contains mainly methane as major component and smaller amounts of ethane, propane, and butane. fractional distillation of petroleum provides us different hydrocarbons. After learning some general facts about alkanes, we will gain more knowledge about methane, the first member of alkane homologous series. The chemical formula of methane is CH4, and it is commonly known as marsh gas. Methane is the major component of natural gas, which is about 87% by volume. Coal mines, marshy areas, biomass and CNG are some important sources of methane. Look at the structure of methane. It has a tetrahedral geometry and the angle between H, C and H atoms is 109.5 degrees. Moving on, we will learn how we can prepare methane. In the laboratory, methane is prepared from sodium acetate. Other methods of preparation of methane are from alkyl halide, from iodomethane, from aldehyde, and from aluminum carbide. Methane can also be prepared by the reduction of alkyl halide by hydrogen iodide. Moving on, we will learn how to prepare methane by using iodomethane. Iodomethane is reduced by nascent hydrogen to form methane. Nascent hydrogen is produced by the action of zinc powder on dilute hydrochloric acid. Formaldehyde can be reduced by heating it with zinc amalgam and hydrochloric acid to prepare methane. Next method is by hydrolysis of aluminum carbide. Aluminum carbide on hydrolysis at room temperature liberated methane gas along with aluminum hydroxide. Now it's time to test your knowledge. Complete the following sentence. Methane is formed when? And your options are aluminum carbide is reduced, iodomethane is oxidized, sodium acetate is heated with soda lime, and alkyl halide reacts with water. The correct answer is option C. Methane is prepared when sodium acetate reacts with soda lime and collected by downward displacement of water. Going further, we will learn about the physical and chemical properties of methane, beginning with physical properties of methane. Methane is a colorless and odorless gas. It is soluble in non-polar solvents. Methane is lighter than water. The boiling point of methane is minus 162 degrees Celsius, and its melting point is minus 183 degrees Celsius. Coming up next are the chemical properties of methane, which include substitution reaction, combustion reaction, catalytic oxidation, and cracking or pyrolysis. Now, substitution reactions are characteristic reactions of alkanes. Chlorination is a type of substitution reaction. During the reaction, mixture of products is formed by successive substitution of hydrogen atoms of methane. These products can be separated by fractional distillation. Now we will study about combustion reaction. This is the general combustion reaction of alkane, where N is the number of carbon atoms present in the alkane. Alkanes can undergo combustion either in excess of air or an insufficient supply of air. What are the products obtained when methane undergoes combustion in excess of air? Under these conditions, methane undergoes complete combustion to produce carbon dioxide and water. It burns in air with a bluish, non-sooty flame. During complete combustion of methane, large amount of heat is produced, so methane is used as a gaseous fuel. Are the products of combustion of methane or any other alkane in insufficient supply of air same or different from those obtained by their complete combustion? No. Methane and other alkanes in insufficient supply of air form carbon monoxide and water. With still less supply of air, methane forms soot and water molecules. Generally, soot is used in the manufacture of printing inks and tires. Methane undergoes catalytic oxidation and forms different products depending upon the catalyst used and the reaction conditions. For example, when a mixture of methane and oxygen is passed through a copper tube at 475 Kelvin, methyl alcohol or methanol is formed. But when a mixture of methane and oxygen is passed over heated molybdenum oxide between 350 to 500 degrees Celsius, formaldehyde or methanol is formed. Similarly, when methane is allowed to react with oxygen at 100 degrees Celsius temperature in the presence of manganese, different product, that is formic acid or methanoic acid, is formed. Now we will learn about cracking or pyrolysis. Alkanes decompose into a mixture of saturated and unsaturated hydrocarbons, and hydrogen when heated to high temperatures in the absence of air. Such type of decomposition reaction is called cracking or pyrolysis. Methane, when heated to about 1000 degrees Celsius, decomposes into its constituent elements. Let us now study about the various uses of methane. Methane is a source of carbon monoxide and hydrogen. It is used as a domestic fuel. Methane is the starting material for the synthesis of ethine, formaldehyde, methanol, and carbon tetrachloride. Now it's time to test your knowledge. If the molecular formula of a hydrocarbon is C3H8, it will show, and your options are addition reactions, substitution reactions, elimination reactions, and isomerization reactions. The correct answer is option B, substitution reactions. The explanation is that molecular formula C3H8 represents a saturated hydrocarbon. The characteristic reactions of such hydrocarbons are substitution reactions. Let us have a quick recap. Hydrocarbons are the compounds containing only hydrogen and carbon atoms. Alkanes are saturated hydrocarbons. Methane is also known as marsh gas, and its chemical formula is CH4. Methane is colorless, odorless gas and soluble in non-polar solvents.
In this module, we will study general introduction, preparation, physical properties, chemical properties, and uses of ethane.
Methane is the first member of the homologous series of alkanes. On adding CH2 unit to the molecular formula of methane, we get the second member of the homologous series of alkanes and is called ethane. Let us know more about ethane. The chemical formula of ethane is C2H6 and it is the second member of the alkane family. How can we prepare ethane? In the laboratory, it is prepared from sodium propionate. It can also be prepared from bromoethane and from alkyl halide. That is, the mixture of calcium oxide and sodium hydroxide is called soda lime. When sodium propionate is heated with soda lime, ethane is formed. Collected by downward displacement of water, since it is lighter than water and is slightly soluble in water. We can also prepare ethane from bromoethane. Alkyl halide on reaction with nascent hydrogen produces an alkane. The nascent hydrogen is produced by reacting zinc with dilute hydrochloric acid. For example, ethane is formed when bromoethane reacts with nascent hydrogen. Notice that alkane having the same number of carbon atoms as present in alkyl halide is formed by this reaction. Next method of preparation of ethane is from alkyl halide. Alkyl halide on reaction with two molecules of sodium in the presence of dry ether produces an alkane. For example, ethane is formed when two molecules of iodomethane reacts with two molecules of sodium in the presence of dry ether. This reaction is known as Wood's reaction. Alkane having double the number of carbon atom as present in alkyl halide is formed. Now it's time to have a learning check. In the laboratory, ethane gas is prepared by heating a mixture of, and your options are sodium ethanoate and soda lime, sodium propanate and soda lime, sodium ethoxide and soda lime, and sodium hydride and soda lime. The correct answer is option B, sodium propionate and soda lime. Coming up next are the physical and chemical properties of ethane. First, we will discuss its physical properties. Ethane is a gas at room temperature. It is a colorless, odorless, tasteless and non-poisonous gas. The boiling point of ethane is -89 degrees Celsius and the melting point is -172 degrees Celsius. It is sparingly soluble in water but completely soluble in organic solvents. Next in the line are the chemical properties of ethane. They include substitution reaction, combustion, catalytic oxidation, cracking or pyrolysis. The first one is the substitution reaction. Chlorination is a type of substitution reaction. You can see the successive substitution of hydrogen atoms of ethane results in formation of mixture of compounds, which can be separated by fractional distillation. What happens when ethane is heated in excess of air? It undergoes complete combustion and produces carbon dioxide and water. It burns in air with a bluish, non-sooty flame. A large amount of heat is also produced during the reaction, so it is also used as a fuel. In insufficient supply of air, ethane undergoes incomplete combustion and forms carbon monoxide and water. Now we will learn about catalytic oxidation of ethane. Like methane, it also gives different products on reaction with different catalysts at different conditions. For example, ethane forms ethanol on reaction with oxygen at 120 atmospheric pressure and 475 Kelvin temperature. Ethanol can further be oxidized to acetic acid. When a mixture of ethane and oxygen is passed through heated molybdenum oxide, a different product, that is ethanol or acetaldehyde, is formed. What happens when ethane is subjected to cracking or pyrolysis? When ethane is heated to high temperature in the absence of air, ethene and hydrogen are formed. Now it's your turn to answer the question. When ethane is burnt in insufficient supply of air, it produces, and your options are carbon dioxide, carbon monoxide, sulfur dioxide, and nitrogen dioxide. The correct answer is option B, carbon monoxide. It's time to discuss the various uses of ethane. Ethane is used for making ethyl chloride, which is used for making tetraethyl lead. It is used for preparation of ethene, ethanol, ethanol, ethanoic acid. Let us have a quick recap. The second member of alkane family is ethane, and its chemical formula is C2H6. Ethane is a colorless and odorless gas. It is sparingly soluble in water and completely soluble in organic solvents. It is used in making ethyl chloride, which is used for making tetraethyl lead. In this module, we will first study about the alkenes. Then, we will learn about ethane, its preparation, physical properties, chemical properties, and uses. Hi, I am polythene. All of you use me daily in various forms. Do you know my parent compound? Parent compound of polythene is ethene, which is an unsaturated hydrocarbon. Do you know what are hydrocarbons? Hydrocarbons are the compounds containing hydrogen and carbon atoms. Number of hydrocarbons is very large. So, for better understanding, they are classified into three groups, namely alkanes, alkenes, and alkynes. Alkanes are hydrocarbons which have single bonds between carbon atoms. Alkenes are the hydrocarbons which have at least one carbon-carbon double bond. And alkynes are the hydrocarbons which have at least one carbon-carbon triple bond. Let us know alkenes are unsaturated hydrocarbons with at least one carbon-carbon double bond. They are more reactive as compared to alkanes due to the presence of double bond. The first stable member of alkene series is ethene, which is commonly known as ethylene. What is the general formula of alkenes? The general formula of alkenes is CnH2n containing at least one double bond. What does this mean? If N is equal to 1, then we get the formula of the first alkene as CH2. But no alkene is possible by the formula CH2 because presence of two carbon atoms is a must for the formation of a double bond. If N is equal to 2, then the hydrocarbon thus formed is C2H4 and it is called ethene. The names and molecular formulae of first 6 alkenes are shown in the given table. Moving on, we will learn about the isomerism shown by alkenes. Alkenes with 4 or more carbon atoms exhibit isomerism. They show position and chain isomerism. Position isomers of alkene differ in the position of carbon-carbon double bond. For example, the position isomers of butene are but1ene and but2ene because they differ in position of carbon-carbon double bond. Chain isomers of alkene differ in the length of carbon chain. For example, but1ene and 2-methylpropene are the chain isomers of butene. Now we will study about the occurrence of alkenes. Alkenes seldom occur free in nature. Lower alkenes occur in minute quantities in coal gas. They are produced on a large scale by the cracking of petroleum. The first member of alkene series is ethene. In the forthcoming slides, we will learn more about ethene. The molecular formula of ethene is C2H4 and it is commonly known as ethylene. Now, we will discuss about the structure of ethene. Each carbon atom of ethene is attached to 2 hydrogen atoms by single covalent bonds and to another carbon atom by a double covalent bond. It is a planar molecule and all bond angles are of 120 degrees. Now it's time to test your knowledge. Alkenes exhibit, and your options are Option A, chain isomerism only, Option B, position isomerism only, or option C, both chain and position isomerism? The correct answer is option C, both chain and position isomerism. Now, let us study about the preparation of ethene. Ethene can be prepared by the following methods. In laboratory, it is prepared by dehydration of ethyl alcohol. On industrial scale, it is prepared by dehydration of alcohol. Ethene can also be prepared by dehydrohalogenation of haloalkanes and cracking of alkanes. In laboratory, ethene can be prepared by the dehydration of ethyl alcohol. During this process, ethanol reacts with sulfuric acid to form an ethyl hydrogen sulfate with water molecule. Ethyl hydrogen sulfate, thus obtained, further reacts with excess of sulfuric acid at a temperature of 160 to 170 degrees Celsius to form ethene. This reaction is called dehydration reaction because removal of water molecule takes place during the reaction. Let us watch the upcoming animation for a better understanding.
Nature has blessed us with so many fruits. We all love to eat fruits and have some personal favorites too. Mango is said to be the king of fruits. However, we get mangoes only in one season. Thanks to science, a chemical is now being used to ripen mangoes faster and make them available throughout the year. The chemical used is ethene, with 2 carbon atoms and 4 hydrogen atoms. This is first member of alkene family. Alkenes contain at least one double bond. Ethene, propene and butene are some of the hydrocarbons that belong to the alkene family. Can you derive the general formula for alkenes? Check out the numbers of carbon atoms. It increases one by one. Coming to the hydrogen atom, it is 4, 6 and 8 respectively. When we compare the number of hydrogen atoms in alkenes with the respective alkanes, we can say that each member has 2 hydrogen atoms less than corresponding alkane. So, the general formula of alkenes is CnH2n. Let us now prepare ethene. Take about 20 to 25 ml of ethanol in a round bottom flask. Add concentrated sulfuric acid with the help of thistle funnel. Now, heat the mixture until the temperature of flask is raised to 160 degrees. Notice, ethene gas starts evolving and can be collected over water by downward displacement of water. Ethene is used in making polythene bags. It is also used for making ethylene glycol, which is used as an antifreeze substance.
On industrial scale, ethene can be prepared by passing ethanol vapors through a tube containing alumina at 300 degrees Celsius. The next method of preparation of ethene which we learn is the dehydrohalogenation of haloalkanes. Dehydrohalogenation reaction involves removal of hydrogen and halogen. Haloalkanes are halogen derivatives of alkanes. In this method, ethene is prepared by dehydrohalogenation of chloroethane or bromoethane or iodoethane with alcoholic potassium hydroxide. Catalytic cracking of alkanes at high temperature and pressure yields alkenes. In this method, ethene is prepared by the thermal decomposition of ethane in the presence of a catalyst that is a mixture of silica and alumina under high pressure and at a temperature of about 500 degrees Celsius. Now it's time to test your knowledge. Complete the following sentence. For industrial use, ethene is prepared by dehydration of, and your options are option A, ethanol, option B, methanol, option C, propanol, and option D, butanol. The correct answer is option A. Here is the explanation. Ethene can be prepared by passing ethanol vapors through a tube containing alumina at 300 degrees Celsius. Now we will study about the physical properties of ethene. Ethene is colorless and inflammable gas having a faint sweet odor. Its boiling point is -102 degrees Celsius. It is sparingly soluble in water but highly soluble in organic solvents. It produces anesthetic effect upon inhalation. After learning about the physical properties of ethene, now we will learn the chemical properties of ethene. The important chemical properties of ethene are as follows: addition reactions, ozonolysis, polymerization, oxidation, and combustion. Let us discuss about them one by one. Addition reaction is the reaction in which an unsaturated hydrocarbon combines with another substance to give a single product. Ethene, being an unsaturated hydrocarbon, undergoes the following addition reactions: addition of hydrogen, addition of halogens, addition of water, addition of hydrochloric acid. Let us begin with addition of hydrogen. Ethene combines with hydrogen in the presence of a catalyst like nickel or platinum to form ethane. During this process, carbon-carbon double bond is converted into single bond, which means unsaturated compound becomes saturated. This reaction is known as hydrogenation reaction. Halogens are added to the double bond of ethene at room temperature in the presence of light to form saturated compounds. For example, chlorine reacts with ethene in the presence of light to form 1,2-dichloroethane or ethylene chloride. Similarly, bromine reacts with ethene in the presence of light to form 1,2-dibromoethane, which is commonly known as ethylene bromide. Unsaturated hydrocarbons decolorize reddish-brown color of bromine solution in carbon tetrachloride. This reaction is used for detection of carbon-carbon double and triple bond in organic compounds. Now it's time to test your knowledge. From the listed options, which hydrocarbon will decolorize the color of bromine solution in carbon tetrachloride? The correct answer is option D, ethene. Here is the explanation. Ethene, being an unsaturated hydrocarbon, decolorizes the color of bromine solution in carbon tetrachloride. Next chemical property of ethene, which we will study, is addition of water. The addition of water is called hydration. A water molecule is added to alkenes in the presence of sulfuric acid to form alcohols. For example, ethene on hydrolysis forms an ethanol. Let us see how ethene reacts with hydrochloric acid. Ethene, on reaction with hydrochloric acid, forms chloroethane, which on further reaction with aqueous potassium hydroxide forms ethanol. Ethene on ozonolysis, in the presence of ether, forms ethene ozonide or ethylene ozonide. Going further, we will now study about polymerization. Polymerization is the process in which a larger number of simple molecules of an unsaturated compound combine to form a large molecule at high temperature and pressure in the presence of a catalyst. For example, ethene on heating at high temperature and pressure forms polythene in the presence of some catalysts. Ethene is a monomer of polythene. Now we will learn about the oxidation of ethene by potassium permanganate solution. Ethene reacts with cold dilute potassium permanganate to form ethane 1,2-diol or ethylene glycol. It decolorizes purple color of potassium permanganate. This reaction is also used for the detection of unsaturation, that is, presence of carbon-carbon double bond and carbon-carbon triple bond in organic compounds. Alkanes do not decolorize potassium permanganate. Alkaline potassium permanganate solution is also known as Bayer's reagent. The last chemical property of ethene which we will learn is combustion of ethene. Ethene burns in air with a sooty flame, producing large amounts of heat. If the supply of air is in excess, it burns with a pale blue flame to produce carbon dioxide, water, and a large amount of heat. Now it's time to have a learning check. Complete the following sentence. Ethene produces polythene on, and your options are option A, polymerization, option B, oxidation, option C, combustion, and option D, reduction. The correct answer is option A, polymerization. Here is the explanation. On polymerization, ethene produces polythene. Now, we will learn about some important uses of ethene. Ethene is used for cutting and welding purpose. It is used in artificial ripening of fruits. It is also used in the manufacture of detergents and in making polythene. Let's have a quick recap. Hydrocarbons are the compounds containing hydrogen and carbon atoms. Alkenes are unsaturated hydrocarbons with at least one carbon-carbon double bond. The general formula of alkenes is CnH2n, having at least one carbon-carbon double bond. The first member of alkane series is ethene. The molecular formula of ethene is C2H4. Ethene is colorless and inflammable gas with a faint, sweet smell. It is sparingly soluble in water but highly soluble in organic solvents. Ethene is used in the manufacturing of detergents, making of polythene, etc. It is also used for cutting and welding purposes.